Next topic we will look at is a firewall. So as I said, firewall actually is one type of intrusion prevention system. It will determine whether a packet from the network can enter the network or leave the network. So it's like a choke point of the local network. So you have an internet, and then the firewall is like a choke point. So basically, any traffic needs to go through the firewall, and then the firewall will determine who can pass, who will be like dropped by the firewall. So it's like a filter, right? So at the filter, actually we can do the filtering on different like layers, in different layers of the TCP/IP protocol. Right, so the firewall is to protect the internal network. So we use a firewall to protect the entire internal network against the attackers from in the external network. So basically we assume. So the firewall here we assume. So there are a few assumptions used by firewall. First, we assume any packet will need to go through the firewall. So this is like some assumption on the topology of the network. We assume there is no other path that can connect to the internal network. Although in reality this assumption may not be true. In general, we assume at least the majority of the packets will need to go through the firewall. They cannot directly connect to the internal network. So this is one assumption on the topology of the network. And the second assumption is actually we assume the attacker is not from the internal. Because if the attacker is in the internal network, then the attacker does not need to go through the firewall. The firewall is just to monitor the inbound and outbound traffic for internal network. So if we have some insider here, then they can bypass the firewall because they don't need to go through the firewall to attack another machine. And then of course we need to assume the firewall is trusted, right? So if the firewall is not trusted, then we cannot really do anything. Okay, so that's basically the general structure of the firewall, general function of the firewall, and then some assumptions we need to make on the firewall, right? So basically the firewall is useful for like enterprise network or like organizations and so on. So because for this kind of like large networks, like it's very expensive to apply some like a security mechanism on individual machines. So in this case, we try to put an entity that can protect the entire network. So that's why we introduce this firewall, right? So depending on the structure, the topology of network, so even inside the internal network, we may have some internal firewall as well. For example, different departments, they may have different local network, and then between the local networks, they can also have firewall. For example, as I said, if you only have a firewall for the external network, then you cannot prevent insider. If you have an internal firewall for different like departments, then you can still prevent, for example, one employee in one department A to access information in department B. So, however, so if the employee A in one subnetwork tries to access another machine in the same internal network, then of course we still cannot prevent this kind of attack. Basically, the firewall can only protect the communication that will cross like either subnetwork or like between the internet and the external network, right? So the benefit brought by the firewall is like the low cost for implementing this access control from network. Because if you have a firewall on each individual machine, of course nowadays actually each PC can also have a software firewall, right? But the purpose actually is different. So the personal firewall actually is to, for example, to determine whether someone can remote control, can do like a remote desktop or remote like connection to your machine. And then the functionality actually performed by the software firewall is quite limited in comparison with the tailor-made firewall for the entire network. Then, of course, the software firewall can still provide certain degree of protection. For example, if someone who want to have a remote desktop on your machine, then the firewall may block such kind of requests. Okay, so this is the reason, as I said, it can be very expensive if we want to implement very strong security in individual machines. So individual machines, they can still have the software firewall to do some protection, but the majority of the tasks can be passed to this tailor-made firewall instead of your individual software firewall. So software firewall just can be a complement of this real firewall, and the real firewall will be much like will do like a more complicated, like we will try to prevent more complicated attacks, and then it will be more in terms of functionality. This firewall will be more advanced compared with your personal firewall. Right. So if you put all those functionality within the internal, like each individual machine, then it will become very costly. So design requirements, as I said, there are some assumptions, right? So the first assumption then is about the topology of the network. We assume the firewall is only pass the traffic can go through. So if there are some other paths that allow the attacker to connect to the internal network, then the firewall actually cannot protect those, cannot really filter those communications, right? So, and then only the authorized traffic should be allowed to go through firewalls. And then basically later we'll see the firewall will define some rules. So the rule is somehow similar as the access control matrix. So the firewall now basically will determine whether a packet is permitted or not based on some attributes of the packet. For example, the IP address, the port number, and some flags, whether, for example, the one particular flag in the IP header is on or off, right? So this can be determined in a table. Later we will see. There will be like a table. This is like an access control type table. We will determine for a particular packet whether it's allowed or it's denied by the firewall. Right, so also the firewall must be trusted, and the firewall should be invulnerable. Also, this part is a little difficult to guarantee because we may not be able to guarantee the firewall does not have configuration error or does not have vulnerability, but we try to make sure the firewall is less vulnerable. So how to ensure that? Basically, later we will see. We try to install firewall on some specific device which does not install other applications. Right? So in this case, we try to isolate the firewall from other systems so that they will not be affected by other systems. Just like if you look at the mobile phone, I said if you have many applications on your smartphone, the system may crash if one of them crash. Right? But if you use the old generation, like the second generation mobile phone, actually it's very stable. So that means we only have the very specific functionality performed. So here is similar. We will try to put firewall on some tailor-made systems so that they will not be affected by other systems. Right, so the general control, so we can control what kind of packet can enter the network and what kind of packet can leave the network. So basically we can do the service control. For example, we can use IP address and TCP port number. Say you allow anyone to access a web server on a particular IP address and TCP port 80, right? But you prevent all the packets to access another IP address with a particular port number, right? So in this case, so suppose the service is only for internal user, then you can, for any packet, try to access this service, this address and or port number, then you can just block all the traffic. Direction control, you can control so both inbound and outbound traffic. So what kind of packet can go in, what kind of packet can go out. So user control, actually we can also do the control for the users. So this can be done by using some specific firewall. For example, you can use the so-called proxy server or application gateway to do authentication, to do user authentication. For example, if you work in a company, sometimes you are not allowed to access some external website and so on. So you need to like pass through a proxy server in order to access the service. So in this case, actually, we can do the user control. So some users they may be allowed to access some external server, but other users they are not allowed because the proxy server essentially will control. By doing like user authentication, the proxy server can control who can connect to some external service, who cannot. So in this case, we can also do the user control, right? Behavior control, and then we can also basically, for example, block certain connection requests. For example, if you say, the example I just mentioned, if you detect, the firewall detect, there is like there are packets that are like detecting, that are scanning the port, a particular port for all the machines in the network, then the firewall can simply stop all the future packets, all the future connections sent by a particular address. Alright, so this is what the firewall can do. So as I said, it will provide a choke point to protect the internal network from outside, right? So this will simplify the management, and then we will also reduce the cost because you use one point to protect the network. Of course, the disadvantage is if this point is this point fails or this point is corrupted, then the entire network may be in like a dangerous state. However, later we will see. So in some firewall like architecture, we try to somehow like address a single point of failure. So we try to make sure even if say one firewall fails, then the entire system will not be like compromised. So we will see some architecture used by different configurations of the firewall, and then monitor the traffic so we can see basically which packet is. So all the traffic from external and internal machines, right? So we can also try to detect if there is any attempt for the security breach. Right, so as I said before, we can also do some additional functionality. So this is, for example, the network address translation. So it means you can hide the internal network from the external network. That means the internal network, they will see, say, a server with a particular address A, but the firewall will translate this address A to a different address. From the external network, external users, they will see a different address. So in this case, we can hide the internal network structure. So this is the network address translation. So for example, if we use so-called dual home firewall architecture, actually we can separate the two interfaces. One is the internal interface, one is external interface. The firewall basically will divide these two parts. So the internal will have only access to the internal interface, external only can access to the external interface. Then the firewall can do the translation among the addresses. So what can the firewall do? So as I said, firewall cannot protect against internal attackers unless you have the internal firewall installed, right? So otherwise, you cannot really protect some internal attackers to attack another machine in the internal network, because if the traffic does not pass through the firewall, then the firewall can do nothing, right? So essentially, this also links to the third point. So if there is any path that can bypass the firewall, then the firewall can do nothing, right? So, for example, if you have a dialing service, and the dialing service does not pass through the firewall, then in this case, actually, you cannot protect malicious packet. You cannot prevent malicious packet from the dialing network. Or if you have a Wi-Fi set up by a malicious insider, say the malicious insider actually can access the internal resource, but the malicious insider may install a Wi-Fi access point, and then this Wi-Fi access point allow other external users to connect to this access point. So in this case, you have a new path that can connect to the internal network without going through the firewall. So in this case, actually, the firewall can do nothing as well. So And also the firewall actually cannot protect against malware or programs infected by malware, right? So firewall is only to do the filtering of the packet. So, okay, so the types of firewalls, actually we will look at some typical examples of firewalls at operating at the different network layers. So if you remember in the beginning of that, I mentioned the TCP IP actually have like 5 layers. It's a multi-layer structure. So you have application layer, transport layer, and IT layer, internet layer, data link layer, and then the MAC layer, right? And each layer actually we can have a type of firewall. So then the filtering is basically based on the header. So the header in different layers, because in each layer the header contains different information, right? And then, for example, the application layer, you may have the application header, right? And the transport layer, you have the TCP port or UDP port, right? So TCP header or UDP header. IP internet, you have the IP header. Data link layer, you also have the header, the data link layer header, which contains like the physical address or MAC address, right? So we can use all those information for the filtering, right? So the most common one is the so-called packet filtering firewall. This is like the first generation firewall. So this kind of firewall will do the filtering based on the IP and based on IP protocol and then the transport layer protocol. So in general, so they will do the filtering based on the IP address, port number, and then all the like fields and all the flags in the IP header and the TCP header. Because in IP header and TCP header, there are a lot of information that can be used for filtering purpose. Of course, the most important information is address. IP address is in the IP header, the TCP port number or UDP port number, they are in the TCP header or UDP header, right? So we can do some filtering. So essentially the firewall will give a defined table. So you just search the table. Say if for this packet, if the IP address, port number, and the flags and so on, they match the root in the table, then we allow the packet. Then if say they don't match any of the rules, then we just drop the packet. So essentially it's similar as in access control matrix. We just check. If there is a rule saying that this packet is allowed, then we allow it. If there is no such rule, then we apply the default deny. By default, we should deny all the packets that are not specified by this access control table. Okay, so here basically is whether we use default deny or default allow, right? So for security, we should always use default deny. So basically, if we use default allow, then there may be some issues. So if there is undefined situation, or if you have some stored, then the firewall actually does not specify what are the rules for these new services. In this case, we should default deny, because otherwise this new service may become target, may become the vulnerable point. Right. So these are the reasons why we should not use default allow option. Right. So the packet filtering firewall. So the advantage is it's very fast. Any question? Any question? No? Right, so just don't disturb your classmate, right? So maybe you are familiar with the content, you are maybe you have some experience in configuring the firewall, but just try to keep quiet. So packet filtering firewall is very common, most common firewall. It's very simple and it's very fast. So usually this kind of firewall will be installed on the router of the network. So in this case, basically the router will do the filtering based on the IP address, like IP header, TCP header, and so on. However, so the disadvantage of the packet filtering is it cannot examine the application data. So if the application data actually contains some like illegal information, then the packet filtering firewall cannot really do the filtering. For example, maybe you try to connect to a gambling website from your from your company like internet. So in this case, actually, so if the address like this IP address is known to be like a bad website, then we can still use a filtering table to deny this kind of traffic. Say if this is unknown, this address is unknown, then basically the firewall cannot really filter the packet. So we will need some application level firewall. So later we will see some application level firewall that can do the filtering, right? So the disadvantage of this packet filtering is it can only filter data in the lower layers of the TCP/IP stack. So it cannot filter the up layer data. Right. So if this is a picture illustrating the TCP/IP. So in general, we consider TCP/IP as a 5-layer structure. So we have application, transport, internet, data link, and physical. Right. Although in some like old documentation, we consider TCP/IP as a 4-layer. But now we consider it as a 5-layer in order to match the OSI reference model. Because OSI is a reference model like a template for network, like a communication protocols. So we try to make the TCP/IP consistent with OSI. That's why we divide the last one into 2 layers. Right. So let's look at some example how to do the filtering. Suppose you have a local network here, and the firewall is installed at the router, the external router of the local network. Now we have some different like servers running on the internal network. Like we have a web server, right, running on W, then port number 80. We have a SMTP server running on M, right? This is another server running the emails. SMTP is the email, right? So the email server, and then port number is 25. So these port numbers are predetermined. So many port numbers are already determined by some other by different services. And then actually you may install another server on the same machine, but with a different port number. So basically you can install different services on one machine, on one server. They share the same IP address, but they use different port number. Right? For example, SMTP will be like IP address like a 1.1.1.123. So this is for the mail server and the DNS server, but they will use different port number. One uses port 25, DNS maybe port 50 something. So in this case, we have 3 servers, right? One on this W, 2 on this M. M is for mail and the DNS server. And then we also want this is basically we want outsiders to access web server here, the public web server here, the SMTP server here, and the DNS server here. So this is the packet, the inbound traffic that are allowed. For the internal users, we allow them to send email through this SMTP server. So the SMTP server can basically send email on behalf of the user to other SMTP server on the external network. Right, so this is allowed. Access the external NTP server. So NTP is a network time protocol. So we allow users here to access external NTP server. We allow the DNS server on M to build query to other DNS servers. Right, DNS is a domain name server, so it can map, for example, the URL to the IP address. Right. Actually, in your individual PC, you can also specify the cache. Or if there is a file, you can configure the DNS like a cache. So you can tell your machine for this particular name what is the IP address, right? So, but the DNS server actually is in general, we do not use our local cache, but we use DNS server. So you can access the DNS server, and then the DNS server will translate the address for you, right? So all the other traffics are disallowed. So suppose we have such kind of filtering rule. Then we can basically summarize. So these are the inbound traffic, these are the outbound traffic. And then we can define the table. So table will determine the rules. This is similar as access control. So only when the packet satisfies the rules defined here, they can go through. Otherwise, if they are not specified here, they will be rejected. Alright, so we can have an example for the first rule. So we don't list all the filtering rules here for the previous example. We just look at the first one, right? But you can develop the other, like the entries or other rules easily, right? So and in the textbook, actually you can find more examples. So in this example, so we want to allow external user to connect to the local internal web server. So the web server says it's a public web server of the company. Anyone from the external can connect to this web server. Alright, so basically we can set the rule like this. So for any inbound traffic, that means if the packet is from external to internal, from any source address, if the destination is a web server, protocol is TCP, and then the destination port is 80. This is the web server port number. Source port is greater than this one, because for most of the port numbers below this range, actually they are used by some like a popular or like a predefined services. So usually when you run some client or like a email or web client, they will use a port number greater than this one. So for any like source address, any port number greater than this one, for destination port this one, destination address this one, destination port 80, then this acknowledgement, actually this is one of the flag. So this is one of the flag in the TCP using to identify the status of TCP packet. Right. So if the acknowledgement is either 0 or 1, on or off, then we commit. Right. Then for the outbound traffic, we allow the web server on this address and this port number to send response to any destination and any port number greater than this one. Now the acknowledgement is flag must be yes, right? If it is no, we should block. Why here we make a difference? Because if you still remember the TCP protocol, there's a 3-move handshake. So the client sends a request. So for the first message, if it is a request, there is no acknowledgement. So this acknowledgement flag is off. For the server to send a second message, it contains a sequence number from the server and also the acknowledgement for the first message from the client. So in this case, the second message from server contains the acknowledgement for the request. So in this case, the acknowledgement flag is on. And the third message from the client is also acknowledgement for the first server sequence number. So the acknowledgement flag is also on. So that means for the client, the first request acknowledgement is no, but the third message acknowledgement is yes. So either is yes or no, we allow. But for the server, it will never send a message with acknowledgement no, because the server will not send a request. Server will only receive a request. So in this case, we only allow the server to send packet if the acknowledgement flag is yes. Right, so that explains why here we put yes, but for the inbound we put either yes or no. Both can pass the firewall. Right, so this actually shows we can use the flags in different like IP and TCP headers. In both IP and TCP headers to also define the rules whether a packet can go through or not. So because here we are considering TCP protocol, so it's 3-move. Only the first request contains flag no. The second and the third message will have a flag yes. The acknowledgement yes. Right? So in this case, we can define the rule for the first like a filtering rule. Right, so the table we saw just now actually is a so-called static filtering. That means the table is predefined. The firewall will just follow the rules in the table. But sometimes actually we can also define, so in more advanced, so in a later generation, actually we can allow the dynamic packet filtering, right? So basically in this case, actually the firewall can change the rules dynamically based on the event happened. Right, so static one is the first generation firewall, but the dynamic packet filtering actually is a later generation of the firewall. Right, so one example here for the dynamic filtering is the so-called stateful inspection firewall. Right, so in this case, we will, based on the previous event, we will determine whether a packet can go through or not. Sometimes we will say yes, sometimes we will say no. For example, the stateful inspection firewall, it will keep on top of the normal rules, there will be some other rules based on the state of the connections. For example, for the UDP protocol, for example, UDP is unreliable. As I said in the worm, in this slammer worm, UDP is you just in UDP basically you prepare packet and send packet. You don't need to do the handshake, right? So in this case, so we may allow UDP packet, the inbound UDP packet goes through only when there is a previous UDP packet going out. So in this case, we do not allow the external user to connect to initiate the request to connect to the internal network. But we allow internal network to initiate request to external network. That means if someone internal send a packet to the particular external address before, and then when this address send a response, we allow. But if there is no one sending this request before, someone try to send a packet to the internal network, then we block. So in this case, depending on the situation. So sometimes we can allow, sometimes we will block. Of course, this will be more secure or accurate, but the cost is also higher. So that's the disadvantage. And then that's packet filtering. So that's the most common type of firewall that can be installed on just a router. And then the application level gateway. This is a supplement of the packet filtering. So sometimes we call it a proxy server. So in this case, basically because the packet filtering cannot do filtering at the application layer. It can only do the filtering at the lower layer. So for the up layer, actually so some of the application level gateways, they also do the filtering at the transport layer, right? So if you look at some they call them sometimes call them circuit level firewall. For example, one example is the SOX 5, right? So that kind of firewall is for the circuit layer or the we can treat them as that's session layer. So in the ISO structure, that's the session layer. So for those kind of basically we can treat all these as application level gateways. They will do the high level filtering. So in this case, you can even do the user authentication. So in order to allow the packet to go through. For example, if you want to access some service in your company network, so you may actually go through a proxy server. You need to pass authentication, then you can connect to the external service. Right. So this kind of firewall will do the filtering at the higher layer. That cannot be done by the packet filtering firewall. Right. So one example is this SOX 5. So SOX 5 is also at the application layer. Sorry, not the transport layer, application layer, because that's if you look at the OS side, I think it's at the session layer, right? So OS side is for the TCP/IP is the application layer, and for OS side is application session or presentation layer. So these three corresponding to application layer in TCP/IP. And the SOC 5, I think, is at the session layer for the OS side. So we can use that kind of proxy server to do authentication, for example. Right, so, and then below the packet filtering, actually we can also do we can also have a firewall. So this is called a MAC layer firewall. So the MAC layer firewall actually implements as a data link layer, not a physical layer, data link layer, because we use a MAC address. Right, so data link layer, we also have the header. Inside header, we also have like a physical address or MAC address. For example, in your home like a wireless router, you can specify what are the MAC addresses that can connect to this wireless router. So when you configure your home like a wireless router, you can put your MAC address. For example, you have only 3 devices in your home, then you can put the MAC addresses in the configuration. Then only those 3 devices actually can connect to this wireless router. So other devices, if they try to connect, then this router will just reject all the packets. So in this case, we can do access control as the lower layer, as like data link layer, right? So in this case, we can like only allow certain devices to with a particular MAC address or physical address to connect to this network, to your home network, right? So that's the MAC layer firewall. And then we can also have different architectures based on where we place the packet filtering firewall or the proxy server or the application server, application layer firewall, right? So usually we call the place where we put the proxy server or application application layer firewall, the so-called bastion host. So bastion host basically is a term to describe some critical component in network security. So usually we put the proxy server in this bastion host. So basically, depending on how you place the bastion host and the packet filtering router, so the packet filtering is done by the router, and then application level gateway, actually you can put in the bastion host, and there can be different proxy servers, actually different types of proxy servers. You can put some in the bastion host, right? So this is a so-called single home bastion host. That means we have one packet filtering router and then one bastion host. So in this case, all the packets will first go through. For all the external packets, they need to first go through the packet filtering router. That means we first do the filtering on the IP address, TCP address, and so on, TCP port address, and so on. So we do one round of filtering using the packet filtering router, and then other packet will be passed through the bastion host, and the bastion host basically will do the filtering on the application layer, right? So we separate the filtering on the lower layer and the upper layer into 2 machines. Right, so this is the so-called single home bastion host. However, so some packets, they may still be, after they pass through the packet filtering router, they may still be able to go through the network without passing through the bastion host. So you can determine, for example, what kind of packet should go through the bastion host by configuring this router. Packet filtering router. So some of them will need to pass through the bastion host. Some of them can directly pass to the internal network. And then, so this is some explanation about this architecture, right? So as I said, in this case, there is flexibility in providing direct internal access. So in this case, you can go through the you can just go through the bastion host without any filtering. And the dual home bastion host, now this becomes more strict, because you can see here the line is broken. That means in this case, basically all the packets will need to go through these 2. The first is packet filtering router, and then the second one is bastion host. So now the bastion host basically will isolate the internal network and the external network. Any packet must go through it. And then we can implement, for example, the network translation here. That means for all the internal machines, they have an internal address. For all the external machines, they will see a different address. So they will use a different address to access service, and then the bastion host here can translate the address to an internal address. So in this case, we can have like a two interface. Basically, one is an interface for the internal machines, one is an interface for the external machines. So that's why we call it dual home to the bastion host. And then the third one actually is the most common one. We have a bastion host and two routers. Right, so now this bastion host will be in between two packet filtering routers. One is for the one is the outer, like external packet filtering router. One is the internal packet filtering router. Right, so in this case, basically the traffic need to pass through these two routers. And if one of them fails, actually the other one can still work. And this one is more like robust. And then this one is more common than the previous situation, previous configurations. And in particular, so we create so-called subnetwork here. So subnetwork basically is like a DMZ. So we call it a DMZ. So in this area, right? So this is like a buffer between the internal. This is a buffer area between the internal and the external network. Right. So this is the third firewall configuration possibility. Alright, so we finished basically the firewall. So we look at some like examples, like a packet filtering, and then application level gateway, and then we look at the different architectures.